Hi Vicky, how are you?
Hi Avishai.
Do you remember that we promised to perform a second webinar?
Yeah, sure, I do remember, and it seems that the time has come.
So let's do it, Vicky.
Yeah, let's go for it.
Hello and thanks for joining our second webinar on Cryocoolers for high-end airborne applications. My name is Avishai and I would like to introduce my colleague Vicky. Hello Vicky.
Hello Avishai, how are you? Thank you. Well, I'm very excited from the interesting topic today, which is highly important. We basically see a trend of increasing need for our cryocoolers to integrate in protecting systems for airborne platforms.
So Vicky, what is the agenda for today's webinar?
Okay, so these are the topics for today. We're going to present an interview with the system application specialist. Then we will talk about typical requirements for high-end airborne application. Then we'll discuss on Ricor cryocoolers for high-end airborne applications. And we will finalize with what next and a summary.
Thanks Vicky for presenting the agenda. Okay, so let's start. And in order to better understand the system consideration and requirement, we are honored to present Mr. Jean-Luc Azoulay from MBDA France that will provide an overview from the system perspective.
Well, totally agreed. It will be very interesting to start with Jean-Luc's overview and afterwards to analyze the activities done in the field of cryocoolers to comply with the challenging requirement for such applications.
Okay, so we would like to introduce Mr. Jean-Luc for MBDA. Hello Jean-Luc, and pleasure that you join us, and thank you for that. And we would like to review with you a few topics. Hello.
Yes, please go ahead. I'm Jean-Luc Azoulay I belongs to the division program of MBDA when I'm in charge of electronic warfare developments. And it will be my pleasure to answer your main questions and give us our view on the need for future cryocoolers.
Okay, thank you. So first, please, if you can review a bit about the type of available high-end applications and the need for MWS and DIRCM systems.
Okay, we are mainly developing, producing MWS, even if we are also involved in DIRCM business, but not directly to the part using the cooler. For MWS, we are developing this kind of system and producing them since 30 years. We have several generations of MWS already in use in several aircrafts all over the world. The need we have for cryocooler is mainly big one, capable to produce important cryo capacity. Each system is composed of several sensors. Each sensor having an FEA and its associated cryocoolers. It goes from two sensor allowing to image the overall background around an aircraft to 6 systems doing the same job, but but smaller and more adapted to aircraft capable to have some mask.
Okay, you started to say about the concept of work, a number of sensors. Can you add more about the system characteristics like response time for treat and other key figures that are important for the system?
I would say to what is related to the cooler, the main characteristic is time to cool down. It's a very important feature uh, because it dimension the time of alert in several aircrafts. The current time in this big system is of several minutes, uh, which can go up to 10 minutes in harsh environment, and this is a key figure to improve in the future.
Okay. Any others parameters that you see that you mentioned the cooldown time? Okay.
Obviously, the swap, that is to say, if tomorrow the cooler can be smaller, first of all, smaller, lighter as a second priority, and using less power consumption, it would obviously help integrating them in other applications. Especially on helicopter, for the time being, the MWS in the world are mainly UV. Uh, UV systems have a drastic difficulty to have a range enough wide for this kind of application. Going to infrared would mean having a good swap and low cooldown time. This is a challenge for today in order to sell the MWS on a large amount of platform, and of tomorrow in order to increase the area in which we can install MWS. There is a complete area which is completely inaccessible today for MWS, which are the armored vehicles. There is very few application on armored vehicles for infrared efficient MWS. In order to go to this area, swap and price shall decrease. And as you obviously know, the cooler is a big portion of the price of the system.
Okay. Can you please review a bit about the test that needed in order to validate and evaluate the cooler as part of the system, and all the qualification, and what is the environmental that is very unique for those applications?
Basically, we see the cooler thanks to a DDC, which is provided by the detector manufacturer. That is to say, the main characteristic to integrate the cooler inside DDC is known by the detector manufacturer, Leonardo or SCD or Liquid, it depends. On our side, what is important is the weight. How can we attach efficiently the compressor of the cooler? How easy the thermal drain would be for the compressor, but also for the cold finger. And the environment for, especially on combat aircraft, is very harsh. We have a level of vibration shock which are very high. We have temperatures that can go up to more than 110 degrees C. So this is relatively, as far as I know, limited in application. I don't know other application in which we have so harsh environments. Obviously, the tests we perform include environmental tests, and for the time being, your product has successfully passed them. And we hope that going to lighter and smaller cooler will prevent from not performing the environmental tests we shall perform.
Once you mention swap, so you mean the combination with hot detector, yes?
No, unfortunately, for the time being, the technology swap for MWS is not really available for technological reason. Uh, Keeping the temperature of the FPA relatively low, for instance, for MCT around 110 or 120. For INSB, it could be lower. It would be very interesting if you can decrease mainly the volume more than anything, but also the weight. We have no mean for the time being to use really hot detector. Perhaps tomorrow it would change, but for the time being, it's not accessible for MWS.
How you can see this trend of need for MWS for airborne applications for the next, let's say, 5 or 10 years? Do you see a growth on this area?
Actually, there is plenty of platform actually, let's put it in another way. The fighter and the transport aircraft are mainly already equipped by MWS, and except for the US, they are mainly in infrared. Obviously there is a market, but it will not be increased largely. The large market is, first of all, helicopter, because on helicopter either there is no MWS or they are in UV and the customer want to change them to improve the performance. So there is a huge market on this area. Now on the other market, I would say at a longer time frame is the armored vehicle. But for the time being, this market is hard to access because of the price and the swap of this equipment.
Can you say some few words about the reliability of the system and how the cooler is important from that point of view?
Yes, we can put a little word on that. The reliability we observe on your cooler is very good and actually better than what the computation says. I would say you are very cautious in your computation and the results are better. For the time being, for this kind of application, reliability is not really an issue. It would be another story if we have ground installed vehicle missile detector, which exists. But for our application on aircraft, we don't see it as something as a key factor, because you have already reached a level of reliability which is enough. And we would prefer the effort to go on, as I told you, the swap.
Okay, so I think it was very interesting to host you in this webinar and to get your point of view. So we would like to thank you for joining us. It was a pleasure that you join us for this webinar, and wish you all the best.
You too, thank you, and I hope you will have other very interesting contribution for your webinar.
Okay, thank you, and
thanks, bye.
Bye.
Thank you, Jean-Luc and Avishai. It was a very interesting interview. To summarize, we learned about key parameters that are important for the system, such as high cooling power, cool down time for readiness, compliance with swap, efficient thermal management, exposure to non-standard harsh environmental conditions, and the level of reliability.
Now let's translate this insight into 4 groups of requirements from the detectors and the cryocoolers: reliability, cooling power, environmental conditions, and swap.
Okay, so now let's start with the first topic, and one of the most important, which is reliability. Why the reliability is so important? The reliability is important because the use of a multi-sensor platform and the fact that all the sensors are needed to operate together to make a full spherical coverage. The importance of reliability is not only in terms of MTTF or MTBF, but also in terms of failure distribution around the MTTF. In our life experiments, we calculate also the shape parameter of the Weibull distribution and found it to be relatively high, meaning that there is a narrow failure distribution. This is also very important to reduce the life cycle cost of the complete system and platform. In addition to the MTTF and failure distribution, it is also very important to minimize the infant mortality failures, which is something that we control during our production and tests before we deliver the cooler to our customers. For this requirement, we can offer several cooler models such as the K508N, K549 and K527. All of these coolers are airborne proven and were already integrated with success into multi-sensor systems. The K508N is the first cooler that we present in this category. This cooler, which is more than 10 years on the road and close to 10,000 coolers delivered, was widely tested in our lab, and we found that the MTTF is better than 28,000 hours in basic conditions. In addition, we already have some feedback from our customer that the cooler is operating in a perfect manner in surveillance and airborne application with systems that gain more than 1 million of operating hours. The second cooler that we propose is the K549. This cooler, which is a split rotary, is about 15 years in the field and more than 10,000 coolers were delivered. This cooler is an upgrade of an older version that is still serving in airborne applications for more than 20 years. This cooler has a very low field failure rate in many airborne applications, operating in many different systems and configurations. We will come back to this cooler later when we will see what is planned for the near future. Another cooler that we present is the K527, that is a single piston split linear cooler. This cooler was specially customized to a multi-sensor application that is qualified by many airborne platforms. The lab reliability of this cooler in basic conditions is more than 35,000 operating hours, while the experiment is still running. As you can see, we can offer several reliable cooling technologies based on rotary coolers, integral and split linear. Each cooler is tailored to the specific application and requirement.
So now let's move to the second topic, which is the cooler cooling power. Why do we need high cooling power for these airborne applications? These applications require fast detection and accuracy, which is leading to the need of high frame rate of the FPA ROIC that consume more electrical power. Another key parameter, as mentioned by Mr. Jean-Luc, is the cooldown time, or the readiness of the system, which is a direct result of the cooling power of the cooler. In addition, the fact that in most of the cases you cannot use a hot detector because of the need to cover a full spectral range, as mentioned by Mr. Jean-Luc, combined with the high ambient temperature, yielded the demand for high GR detector heat load. As a result of all this extreme requirement and taking into account a certain redundancy, the need for a cooler with a very high cooling power. The first cooler is the K548, which is integrated for about 20 years in airborne applications and more than 15,000 cryocoolers already delivered. The cooler is an integral rotary and has more than 800 milliwatts of cooling power when operated in 71 ambient and 77 K. It means that the cooler can cool down a large format detector that operates in high frame rate. The second cooler is the K549, which is a split configuration of the K548 and uses the same cold finger, hence can be integrated with the same GR detector. The cooling power of the K549 is about the same like the K548 and can also be used for the same detectors. Because of their high cooling margin, both of these coolers, the K548 and K549, can be used in very high ambient temperatures, in some cases above 100 degrees C. The K544 is the third option of this category and is the most powerful cooler offered for these applications, and having almost 1 watt cooling power at 100 ambient and 95 K. This cooler is a customized version of the K543 and was especially designed for airborne applications.
So now let's move to the third topic, which is the environmental conditions. The high-end airborne applications are characterized by special and harsh environmental conditions, both mechanical and thermal. The thermal requirements can be as wide as -54 C and up to 120 degrees C for storage and for operation. These requirements must be addressed by special design of mechanical and electrical sub-assemblies of the cooler, and also need a close cooperation with the system designer in order to achieve the optimal heat dissipation for the cooler and reducing the cooler's power consumption. Cooler and cooler skin temperature are highly important to cooler's reliability and efficiency, leading to better operability of the sensor and increasing the platform's availability. Some examples you can see right now in the pictures of the K544 and the K549. Another consideration is the mechanical structure of the cooler in order to meet the extreme vibration and mechanical shocks. The challenge is to keep the cooler compact and low weight, but still having the robustness needed for these conditions. Special consideration is taken to the structural mechanical modes, natural frequency, mounting surfaces, and clamping methods. In some cases, the cooler are withstanding vibrations up to 30 G RMS. We can offer solutions with all three categories, like the integral rotary, the split rotary, and the split linear. For each application and set of requirements, we can tailor the optimal solution, as you can see in the 5 cooler models presented here in the pictures.
The last topic is the swap, size, weight, and power requirement, that is also very important. The low volume of the sensor is required to reduce the drag with the air, which is in direct correlation with fuel consumption of the platform. Small size and compactness of the cooler will reduce the sensor volume and weight. Ricor coolers are well known to have an optimal ratio between the cooling capacity and volume, helping the system designer to integrate the most compact solution. In terms of power consumption, it is very important to keep it as low as possible in order not to exceed the allowed operating temperatures. The efficiency of the cooler is the most important parameter to keep the power consumption as low as possible. The K508N and the K527 are great examples of these cooler's options. The K527 is highly recommended because of its low footprint led by the single piston design, and in some of these applications there is no need for the dynamic balancer. As we have seen up to now, there are different cooling options for the airborne applications. But Vicky, what next?
Well, on the coolers roadmap, we are designing 2 coolers that could be integrated into these airborne applications. The first is the K549HP, which the main goal of development is to double the MTTF while keeping the robustness, the environmental conditions, and the cooling power with the same interfaces. The second model under development is the K508C, which is the third generation of the K508 family, which is targeted to triple the reliability of the K508. This cooler will be capable of cooling the same detectors like the K508N is cooling, but with a much better reliability.
Well, Vicky, it seems that all topics well covered in this webinar.
Yes, and I would like to thank Mr. Jean-Luc Azoulay for supporting our webinar, and to all participants. And we now continue to the second part of our live questions. Hello and good morning to you all, to all the attendees that joined to our webinar this morning. Hello Avishai.
Hello Victor, how are you?
Good morning, how are you? We encourage you all to post more questions. We will wait just a second or two until we will see the questions in the chat room. So this is the exact time for you. So I'll give you a few more seconds and we will start with the questions and answers session.
Okay, so we have one question. The question is, what is the MTTF of the K549?
Well, thank you, Avishai. This is a very good question. In general, the calculation of the MTTF is always should be considered as part of the operating conditions. Okay, so we are defining a basic conditions to every cooler model, including the K549. And if we look at the basic conditions, then the MTTF of the K549 is 9,000 hours. However, the real application should define the mission profile and the exact operating conditions, and according to that, we can calculate the MTTF for this profile. In addition, it is important to let you know that we are developing the K549 HP version, which the idea is to double the MTTF of the K549. Means that in each application that the K549 was used, when we use the HP, the MTTF will be doubled. Okay, let's see. Okay, we have here another question. Is the K544 already launched in the market?
Yes, so the answer is yes. The K544 is already launched and is served in an airborne project with harsh environmental conditions. And as you saw, the structure of this cooler is adapted in order to be more robust and to withstand the harsh environmental conditions. So yes, it's ready. And again, this cooler is a derivative of the K543. It's have about 1 watt cooling power, and already serve in a very tough project. The next question is is a question about the K508N that we mentioned that the MTTF is 28,000 operating hours. And the question is at what conditions or what life profile this figure is referred to?
Yes, so thank you. So as I mentioned earlier, on each cooler model we have something that we call the basic profile. When we say 28,000 hours for the K508N, we mean at the basic profile. We have a very accurate and precise list of the basic profile conditions for each cooler model. We can share that information, and we will write down this question and share the information later on. In general, this is a basic condition, let's say medium heat load, close to room ambient, not in accelerated profile. However, in any case, when we have a mission profile, we can calculate the exact MTTF for the program based on the real operating conditions that are expected in this program. Okay, we have another question here. What is meant by a dynamic balancer?
Okay, so the dynamic balancer is, we are referring to it for the K527. I hope that you can see it now. So it means that in this specific model, we are working with a single piston compressor, linear compressor, this part. And if we would like to cancel or minimize the induced forces that apply from this compressor, we're adding a balancer, which is a stack of springs and mass. And then it's operating and canceling the induced vibration. It's mainly important in a light structure of systems, while in airborne projects is less important since the compressor is clamped to a large mass or big mass of the structure, and then the induced forces is quite negligible. So the balancer is more relevant for light structures, but it's an option that we can add or not for this cooler. Specifically on airborne application, we don't use it.
Okay.
Okay. What else?
Just 1 second. Okay.
There is a question if we have more linear coolers than presented here.
Well, of course we have, and we have quite a lot. In this webinar, we are concentrating in those harsh environmental conditions and those coolers that are specialized for these operations. But in addition to that, we have other linear coolers such as the K588 and the K590, which were presented in our last webinar that we've done in the summer. Of course, we can share more information, and we will come back to you with more information about those coolers, which are the K588 and the K590. Let's see another question. Okay, is a ruggedized version of the K580 is planned?
Currently not. We have our standard K580 cooler, which is a rotary cooler that fit for hot detectors. We can say that the design is robust, and we test it in the early stages by qualification and also by halt test, which means that we extended the environmental conditions by the level of higher ambience in order to test and to see that there is enough safety margin and the cooler is enough robust. So such test already performed, and we have confidence with this cooler. If we will see that there is a need for a more robust version or some specific conditions to withstand, then we can consider it. Currently we are running with this model, and it's in a ramp-up position, and we can say that it's well fit for hot detectors. Another question is, can you specify K527 vibration characteristics?
Yes, okay, thank you. So we need to be more precise when we answer that questions. Of course, it is very important if we use the cooler, the K527, with the dynamic absorber, okay, as we can see it here in the picture, or without. Of course, the cooler can operate with or without the dynamic absorber. And of course, the level of vibration from the compressor will be completely different. So we need to know exactly the operating conditions, and based on that, we can come back with an answer. However, it is very important to know that a linear cooler will make forces on the compressing line and the cold head line, okay? And there will be no moment induced on top of that. So it's a very efficient operation in terms of the vibration. Okay. So we have another question here. What is the qualification status of the K508C?
Okay. So just to say, the K508C is the next step in our reliability enhancement in the family of the K508 coolers, which means we started with the K508. Later on, we introduced the K508N, and now we are working on the K508C. Let's say it's take more time that we thought at the beginning, since there are challenges to meet in order to increase more the reliability in rotary cooler. So it's currently in our roadmap, and we plan to complete all the engineering phase and qualification. And the target for this cooler is to be more than 35,000 operating hours in basic profile. which means another step in the reliability, and mainly for 24/7 and others that needed long operation, and it will keep also the operation or the interfaces of the K508 and K508 family, and including fitting from with the same GR detector. Okay. Can you detail the mill standard levels, GRMS and temperatures that were validated for the K549 qualification for the MWS probably application?
Yes.
Yeah.
Okay, so as you may aware, the K549 was originally qualified almost 20 years ago, probably a bit more than that. The original qualification was, let's call it at the standard conditions. Temperatures were -40 C up to 71 C. Level of vibration, I would assume in the area of 10-15 GRMS, but you should look at the exact profile. However, through the years, when more requirements arrived and more demands came from the field, we've tested the K549 for a much higher level of vibration and temperature. We have programs that operate in the area of 20 to 25 GRMS, but again, we need to be very careful when we state the GRMS, because it is more important to know exactly how the level is distributed according to the frequency. We can send that information to the customer without any problem. The K549 is installed in many different conditions that are operating in those extreme conditions, so no problem to share that information. And in addition, we have the K549 HP under development, which is also going to be qualified. We are just preparing the qualification program, and we can share that also with the customers and make sure that the qualification process is according to the needs. Let's see another question. What level of degradation should be expected over time in the basic conditions?
Okay, so it depends on which type of cooler we are talking. Basically, in the linear coolers, there is some degradation over time. The power consumption is increased during time. And then also you can build a kind of a model of prediction in order to see how the level is increased compared to the specification. In the rotary, the typical is a bit different, which means that it's mainly kept more or less stable most of the lifetime. And then the typical way we can see that quite close to the end of the life, there is a quite quick degradation of performances. So this is also a kind of a challenge, and we asked a few times by customers if we can perform some model for end-of-life predictions. So this is the challenge. Since the rotary cooler is keeping quite stable over time, over the life test, and quite close to the end of life, there is a degradation. Maybe we will get to this point later or in the future to deal with the end-of-life prediction, which is we can see that is interesting mainly from a system point of view. Okay, the next one is, what is the advantage when we use K508N instead of K508?
Okay, so the main idea of developing the K508N is to increase the reliability of the cooler with the same interfaces. Okay, so a customer can use a diode that he already designed, or even a diode that was used in the field already, and you can replace the K508 with the K508N. And in general, and every place where the K508 operated, the K508N will be double in operating hours. Simple as that, with the same interfaces and using the same mechanical and electrical interfaces, more or less the same cryogenic performance. So it is quite transparent to the customer to make that replacement. It could be when entering into a new program, and it could be while doing some maintenance service to the same camera or the same system. Okay, so it looks like we've covered all the questions. Let me see here for a second. Yes, so it looks like we've covered all the questions. I think it's a good opportunity to say thank you to all the attendees and to all those who raised their hand and asked some questions. Of course, we encourage you to come back to us and ask for more information and more data over the coolers. We will be more than happy to share that with you. And I think that it's a good time to wrap this webinar.
Yeah.
And
yes.
We will meet next year.
Hopefully, yes.
Hopefully.
So thanks for all attendance, and thanks for you, Victor.
Thank you. There's another comment here. Someone says happy birthday, so happy birthday to you as well. Thank you. Thank you.
Okay,
Thank you all.
Bye-bye.
Bye-bye. Goodbye
Thanks.
to you.
Bye-bye.